Hello, this is INE Foundation Lab 2, Section 2.5 Sprinty Advanced. Okay, before I conclude this section, let me explain what MST is and what we have concluded before. And I will come back and conclude this section. Okay, in previous section, we have concluded two MST regions. One is region 1, 2, 3, and the other one is region 4. And switch 1, 2, and 3 are in region 1 to 3, and switch 4 is in region 4. Okay, we have CIST. This is common spanning tree. It is defined in the IEEE 8221D standard. CIST only calculates a single spanning tree for all VLANs. Then we have PVST and rapid PVST. Then Cisco made PVST Plus and rapid PVST Plus and added more features. PVST Plus and rapid PVST Plus calculate the topology for each VLAN or STP for each VLAN. In PVST Plus or rapid PVST Plus, each VLAN is mapped to single spanning tree instances. We have instance for each VLAN or one spanning tree calculation for each VLAN. And if we have multiple VLANs or n VLANs, we have a number of instances for each spanning tree calculation. In MST is IEEE standard 8221S. MST maps multiple VLANs to an instance, or in other words, one spanning tree calculation or one STP for multiple VLANs. It will reduce number of spanning tree instances or calculation. We can use instance and map multiple VLANs to that instance. The benefit of MST. Okay, in MST we have MST instance, MST and regions. We have regions and instances. Let me first explain region. In previous section we have conquered two regions and number of switches in each region. Okay, we have region. To be in same region, switches must have same attributes. Attributes are MST configuration name. We can configure it by name command on the MST configuration command. On the MST configuration command, we have MST configuration revision number. We can configure it by revision command, and MST instance to VLAN mapping table. These are attributes for switch to become in same region. We can configure it by instance command. Okay, we have in each region we have instances. MST bridge or switch must be able to handle at least these two instances. In each switch, MST switch, in each switch we have, each switch must at least handle two instances. One is internal spanning tree and the other one is one or more multiple spanning tree instances or MSTRs. Internal spanning tree instance, it is called instance 0, 0 or MSTR 0. Cisco name it MST 0. And multiple spanning tree instances we call MSTRs. MSTR start with number 1 or higher, depend on how many instances we create. If you create instance number 1 and map VLAN 10 to 20, it will become MSTR1, and if you create instance number 2 and map VLAN 21 to 30, it will become MSTR2. Okay, instance number 0 or IST or internal span tree. It is default instance used to calculate the topology within the region. On Cisco switcher, this is the default instance of 0 or MST0. Okay, let me show you this topology on our switch. Okay, let's show what we have here. Show spanning tree, MST Configuration. Switch 1 is in region 1 to 3, and we have 3 MSTRs. This is IST internal, and these are our MSTRs 100, MSTR 100, and MSTR 101. We mapped even VLANs into MSTR 100 and odd VLAN numbers into MSTR 101. Same as switch. Two. We have 0 and region 101. This is switch. And switch 4 is region number 4, and we have only IST. We don't have MSTRs. We haven't configured any instances. MSTR. Okay. IST instance is simply an ISTP instance, and the IST is the only span tree that send and receive BPQs. Okay, we have CIST. It is called common and internal span tree. It is collection of ISTs in each MST region, identical to ISTs. In other words, 2 or more MST regions form what is referred to as a CIST. Okay, in our topology, I do and then I will show a span tree MST. Switch 1 is our CIST. Okay, MST Root bridge election. I will explain CIST more in this section. MST Root bridge election. MST has separate root per multiple span tree instance. Okay, this is in this section. In this switch 1, we have three MSTRs. One is MST0. This is default. 100 and 101. Each MSTR has its own root election. If I check, yes, this is IST. This is MST 0, this is root, this is switch for CIST. MST 0 is CIST and IST. MST number 0 is CIST and IST. It is switch 1 is root. It is root for its own region. And MST 100, this is root. Switch 1 is root for its MST 100 and MST 101. Switch 1. If I check switch 2, root is, if I check, let's check switch 1 MAC address. This is 0B00 and root is 0B00. This is switch 1. This is root for MST 0. For MST 100, switch 1 is root 0B00, and for MST 101, this is switch 1 is root, same as on switch 3. Root for 101, for 100, switch 1 is root, and MST, this is root. If I check switch 4 is another region, and switch 4 is regional root for its own region, but MST 0 root is switch 1. Okay, switch 4 is regional root. Let's see. MST elects CIST root as well as regional root. We saw this in switch 4. This is regional root. Switch 4 is own region. CIST regional root is elected in every region, and CIST root is chosen across all regions. CIST root is in all regions. If we have multiple regions, we have only one CIST root, and we have regional root for each region. We have regional root for each region and CIST root for all regions. And in this scenario, CIST root is switch 1, and we have regional root for its own region. And switch 1 is CIST root for all regions and root for its own region. Okay. And MST configuration, we can configure attributes by name and revision number on the MST configuration section. And for make change root election or change root, we can use SPANT MST instance number and priority command. If I have MST SPANT MST 1 and priority 0, this is because this is number 1. This is for MSTIs. It will make switch root for its MSTI. It will make, this is 1, and it will make switch for root for MSTI number 1. And this is priority. If I choose number 0, it will make switch root page within our region, because number 0 is for CIST and IST. Priority start increments by 4096. If I multiply 4096, it will become 8192. Okay, now let's configure this section. Configure switch 3 as the CIST root using second largest priority. Okay, this means this is saying second largest priority. 0 is first lowest priority, and 1496 is second, and this is third. Switch 3 should become CIST root. We have to use, because it is CIST, it will become, we have to use number 0, MST number 0. Okay, so now at this moment CIST root is switch 1. Let's configure switch 3 as CIST root. Spanning T, I will choose spanning T, MST 0. And priority is 4096. Second, this is second last priority. 0 is first and 49 seconds. Okay, now if I do show span T MST, I have confirmed MST 0, and now switch 3 will become CIST root for all region. This is good. But our MST root hasn't changed. This is switch 1. But if I check a switch 1, show spanning 3 MST, now MST 0 and root is switch 3. Let's check switch 3 MAC address. This is 0D00, and this is root with 0D00. Same as on switch 2. Show MST. This is 0D00. If I check switch here, switch 4, show spanning MST. Now our CIST root is switch 3, 0D00. Okay, now configure switch 2 as root for instance 100 and 101. Switch 2 should become root for RMSTR. At this moment, switch 1 is root for RMSTRs. This is switch 1 MAC address. Now switch 2 should become RMSTR. Priority is this one, and let's change lower priority. Config T, spanning T, MST 100, priority 4096, lower than 62.76.8, same as now if I do show spanning T MST, now switch 2 is root for our MSTRs 101, 100 and 101 root. If I check on switch 1 was root for these MSTRs before. Now it should become switch 2. Now root is switch 2. If I check switch 2, MAC address, which one 0C00 and root is 0C00 for 101 and 100. Okay, now conquer switch 4 with parity of 8192 for IST. Okay, this IST we have to use instance number 0. For CIST and IST we have to use with instance number 0. Now let's go. At this point our priority is 32768. It should become 8192. Let's compute this. Compute this parity MST 0 and priority 8192. We'll show this parity MST. Now it is 8192. And ensure that switch 1 disables fast Ethernet 0/1 if any PPTs are received on that interface. Show CDP maybe it should be copy interface Ethernet 0/3. Okay, we have to use span 3. This is BP2 guard. Don't accept BP2 on this interface. This is BP2 guard. Enable. Okay, to verify this, we have to use show span 3 interface 10 0/ what was the interface /1 1/3 detail. Now BPD use guard is enabled on MSTR 101 and MSTR 100 and MSTR BP2 is enabled. Okay, this was MST configuration. I hope you have enjoyed this video and thank you for viewing.